Hello students, in this video we will study about Kirchhoff's laws. See, we have Coulomb's law, we have Gauss theorem, and as we proceed in current electricity, we got Ohm's law, and now we are going to study about Kirchhoff's law. Now, where the Kirchhoff's law is very useful when you have a network of circuit. What do you mean by a network? In which more than one or two components are involved. Suppose let us say I have a resistance, right, and I have another resistance, right, and these two come and meet at a point, and that point is called junction. We call this point as a junction. Now, current is coming through this, let us say I1, current is coming through this I2, let us say. Now I got another component, let us say, and the current is going out through this I3. There is another component which is the resistance here. Through this also current is going out, that is I4, and there is another component, another point in the junction, right, and that is R, let us say next resistance, and this current is coming in, that is I5. Look here carefully. The current, different currents are coming and meeting at a particular point, and that point is called a junction. Now it is similar to a railway junction. In a railway junction, what is happening? So many trains are coming, let us say Delhi railway station, New Delhi railway station. The train comes from Hyderabad, Chennai, Mumbai, and from different places it comes. But remember, all the trains which come inside the junction have to go out. Similarly, how the trains are coming in, they cannot stay there. They have to go out. Like that, the electricity, the current, I1 is coming in. What are all the incoming current? Let us say, incoming current. Incoming current here is I1, right, plus I2, which is also coming in, fine. I3 is going out, I4 is going out, I5 is coming in, so I5. These are the incoming currents, okay. And now, I have on another side outgoing currents, okay, outgoing currents. Now, what are these outgoing currents here? See, I1, I2, I3. I3 is going out, so let me write it I3, and I4 is going out, plus I4. What the Kirchhoff's first law says, that is called junction rule. What the junction rule says? It says that the number of incoming currents, the sum of the incoming currents is equal to the sum of the outgoing current. That means I1 plus I2 plus I5 is equal to I3 plus I4. The sum of the currents entering the junction is equal to the sum of the currents leaving the junction. Yeah? It's just like a railway station, in the railway junction, right? What is the law we are following is law of conservation of charges. Law of conservation of charges. The charges cannot be kept in one place. They cannot be held in some place. Whatever is coming in has to go out. Just like in a pipe, the water coming in, the water has to go out. Similarly here, the current. The incoming currents is equal to the outgoing currents. From this I can say I1 plus I2 minus I3 minus I4 plus I5 is equal to 0. It is nothing but summation of the total currents is equal to 0. That is, we call algebraic sum of the currents at a particular junction. Algebraic sum of the currents at a particular junction is equal to 0, which implies the incoming currents is equal to outgoing current, and it holds by the law of conservation of charges. Okay, now we have learned the first rule because we are going to apply them in different cases. Fine. Now let me take you to the second rule. That second rule, what the second rule is about? Yeah. It is going to use Ohm's law. We are going to use Ohm's law in that, and we are going to study. First and foremost, let me draw a circuit, a network. A network, here in this case, there is a resistance, right? I call it as R1. Here it is connected to a cell, right, which is having epsilon 1. Epsilon 1 is the EMF. EMF is equal to potential difference when no current is drawn from the cell. Okay, that is what we did in the previous video, right? Now I got another cell here, right? It is epsilon 2, and I got a resistance here, that is R2, fine, and it is being connected like this, fine. And let us say, let me complete it like this. This is epsilon 2, this is R2. Now, through this a current is coming out. Let us say the current is I1. Through this a current is coming out. Let us say this is I2. Let us form a junction here. Let us form a point, intermediary point here, and connect another resistance, let us say R3, right? And this is also another junction. Junction is nothing but where two wires come and meet. They are meeting here. And I got another current here, and let me say the current through this is I3. Now watch carefully. We are going to use the junction rule first. What the junction rule says, this is the junction, the sum of the currents entering the junction. What are the current entering? I1 and I2. So I1 plus I2 is equal to the sum of the current going out, that is I3. So we have used junction rule. Now, we are going to use something called loop rule, okay, loop or mesh. They call it as mesh. What is this loop rule or mesh rule is about? Okay, let us watch carefully to understand this. This concept is a bit difficult, right? But listen carefully. What we do, first, there is a positive terminal. Let me call this point as A, this point as B, this point as C, this is D, this is E, and this is F. Now I got a set of symbols I have given. What I do basically, I take the cell EMF of the cell, right? And that point positive, and this is the point A. I start the loop at A. I start from A, I come to point B, and I come slowly to E and then F, and I close the circuit, and this forms a loop. Okay, so the loop is starting A, B, E, F, A. This is one loop, right? So what is going to happen now? This loop, let me take loop A, B, E, F, and where it ends? It ends at A. Started from positive terminal, and now we have to calculate the changes in potential. What Ohm's law says? Ohm's law says V is equal to R into I. Okay, now we have to see in this loop what are all the changes in potential. Okay, let me start from positive, right, and come here. Nothing is there. I come here. There is R3 and there is I3. So the first change is R3, I3. This is one potential difference. And I go further into the loop, right? I come to R1. This is the current I1, and here the same current I1 should come. Whatever goes out has to come in. So the I1 is the current coming in, and the resistance is R1. So plus R1 I1 is equal to how the current is flowing. What is responsible for the current to flow? And that is the cell with the EMF epsilon. So that is equal to epsilon 1. This is equation number 1. Be clear about it. Let me again explain it to you. I want to talk about the second rule called loop rule or mesh rule. In this loop rule, I start from one point. Let me take, for my convenience, I take A, and I take a loop here, that is A, B, E, F, A. It's a closed loop, right? And what are all the changes in potential that is given by Ohm's law? And I found that I3 current is going through R3. So Ohm's law, V is equal to R into I. So R3, I3, that is one value. What is the second change in potential? I come to here and I see R1 and I1. So R1, I1. But that is due to what? Due to the current from the cell epsilon 1. Because of that, I make it equal. Right. Now, I am going to take another loop. Now, what should be the positively the other loop which I have to consider? Right. Now, that is again with the second cell epsilon 2. Epsilon 2 positive terminal, this is C. So, I am going to take a loop C, C, B, right? And then I go in straight E, then I come to D and back to C. That is a closed loop. We have to consider closed loop. According to this closed loop, let us again find out what are the changes in potential. Fine. I start from positive. I come through this I2, 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 I2. Nothing is there. No resistance here. So I come here R3, I3. So again I write R3, I3 plus or minus. It depends on the direction. Fine. It comes like this, right? And again R2. What is the current going out? I2. So the same current I2 should come inside. So R2, I2 is the change in potential which is equal to epsilon 2. This is equation number 2. Now this is the loop I have taken. The loop I have taken is like this, like this, like this, like this. This is the second loop I have taken. Yes, of course it may look very complex. So what the second rule says? It says the algebraic sum of the changes in potential in a network is 0. That is algebraic sum of sigma changes in potential V into I, which is equal to 0. Change in potential is nothing but R into I, which is change V is equal to 0. This is the loop rule. The first rule, the sum of the incoming current is equal to sum of the outgoing current. You can write sum of the currents is equal to 0. What sum? Algebraic sum, positive or negative, has to be correctly considered, and then you will be able to do this. Remember, without doing a numerical, you cannot understand Kirchhoff's law. In the next video, I will do a numerical, and then I hope you will be able to understand much better. Thank you.